Hello, hello.
Hey Gil, can you hear us?
Yes, can hear you well.
Awesome. Maybe we'll just give a minute or two for more people to join in. Awesome. One more minute and then we'll start. Awesome. Let me kickstart this. Hey everyone, whoever has joined in, welcome to Int8, a webinar series by Segmind. Today we have Gil Elbaz, co-founder and CTO at Datagen. The Datagen platform helps companies create high-quality synthetic data with a simple Python interface. Before Datagen, Gil worked in the defense industry as an algorithms engineer, developing a wide range of simulation capabilities and machine learning solutions. He has a master's degree in computer vision from Israel Institute of Technology with a thesis published in CVPR in the field of computer vision on 3D point cloud data. So without further delay, let me welcome Gil. Gil, welcome to the webinar.
Hi, Rohit. Thanks. Happy to be here.
Awesome. Really happy to have you and excited to learn more about your journey. It would be great if you could start by telling us about what inspired you to create Datagen, a whole platform for creating synthetic data.
Sure, definitely. So back in my studies, a while back, right, in the Technion, I really focused on doing different types of computer vision tasks on point cloud data. And so one of these tasks was registration between two point clouds. And to do this, I leveraged different deep learning techniques, but it was very early on in the industry. Now, what happened kind of as I was going is that I didn't have a lot of data. And this constraint made me or forced me to kind of think of different solutions to generate new 3D data. And so after playing around with the problem a bit, I created some very simple synthetic data, just some Gaussian maps, and really just on a 2D surface created a few Gaussian depth maps, and really from that extracted different point clouds. And I leveraged that, and I actually saw a boost in performance. And that was like an initial aha moment. I was like, okay, wait, synthetic data can actually improve model performance. This seemed crazy to me, right? Because at the time we were investing a lot in how do we gather data in order to make things work. And so, fast forward a few years, we looked at the problem at a very high level in the computer vision space of getting the data you need in order to train your model to be, to solve some kind of computer vision task. And the challenge, right, of building these amazing computer vision systems is really a lot in the data itself, right? If you can get the data that you need, there are tools today, there are ways today, there's the methodologies all published on how to create the end application. But if you don't have the data you need, you're pretty much stuck. And so we really thought about this and went on a very technological approach. If the standard approach back then was very operationally intensive to go out and gather data from the real world, then to send it to manual annotation and do this very slow and costly iterative process, we wanted a very technological approach. And so we were really the first company that came out, started generating or creating tools for generating synthetic data in a seamless way. And we've progressed enormously since then. So just at a very high level, you write simple Python code. It's connected to our API, of course. We generate the data at scale on the cloud, package it nicely, and provide it back to the end user. And the cool part is really that we understand and we understood over time that the most important thing, or one of the most important things, is really to give the controls to the end user, because everyone is doing their own computer vision task. They have their own needs. And so we want to give them the ability to create the exact data that they need. And so we really created an engineering tool, right? Granular control, data point level control, determinism, all of these different kind of principles that we built into the product in order to make it a very powerful engineering tool. So that's a little bit on kind of the motivation and also where we are now.
Awesome, very interesting, Gil. Um, I mean, that gives us a good understanding of what the problem was, which is pretty much everyone's waiting for annotated data to feed into their training pipelines, and the requirement is only going exponential today. In terms of, so you've started this like 5 or 6 years back, and off late we've seen a lot of diffusion-based models in the generative AI space, creating images, videos, 3D models. How's simulated synthetic data different from diffusion-based data, like something created by Stable Diffusion, DALI, or Midjourney in some sense?
Yeah, definitely. If I take like a little bit of a step back or look at the high level a little bit on the whole generative AI space, right? In the end, you have some kind of black box, some kind of network. You have text input, text output, ChatGPT, right? Text input, image output. You have DALI, Midjourney, Stable Diffusion, all of these great systems. And there are many different types of content creation or automatic content creation using these diffusion-based systems today. And also the transformer-based systems, of course.
Right.
And so these are amazing, amazing kind of technological leaps that we've seen progress. And we're first of all embracing them. We're using them internally a lot, and I can touch on that in a second. And also I can talk a little bit about the differences between the two. So in order to create really good data, what was really important for us is to have a way to have input that is exact, right? Not to have just text, I want a woman driving in a vehicle, right? That's not necessarily going to give you really good data for in-cabin, let's say eye gaze estimation. So you need some kind of way to create exact input. So that exact input for us is the Python code. It's extremely easy to write on one hand. On the other hand, it's well defined. So we have an exact input, and then the output isn't just visuals that look really good. They are visuals that look really good, right? But they're data, right? And this data is visuals with an enormous set of ground truth that comes with each of the visuals. And this is really pixel perfect ground truth with 2D and 3D annotations that are perfectly annotated, everything coming packaged together in one data point. So you have Python as input, data as output, and this system in the middle. Now, the way that we leverage these diffusion systems is definitely important, right? And so we have an enormous amount of effort actually on the 3D aspects. So we use diffusion models for generating 3D humans, for generating high-res textures, for generating 3D objects as well, and also 3D environments. And so we do a lot of different kind of work with diffusion models, but specifically, we're very, very adamant on the fact that we want our data to be well defined as input and get full data as output that's perfectly annotated.
Got it. So in some sense, what you do is you use generative aspects to create some components like textures or certain aspects of the data, and then use your core system to kind of build out the actual
Exactly.
synthetic data itself.
Yeah, the core system in a graphics engine environment controlled with our software that can run on the cloud in a distributed way at scale. And then we can leverage these assets in a controlled way and create this high quality data with full ground truth. And by the way, don't get me wrong, like Midjourney, amazing, amazing visuals. They look absolutely fantastic. It is very hard to get high quality, consistent data with granular control. As well as the ground truth
Deterministic
from
as
these
well.
kind of systems. Yeah.
Yep, yep. Awesome, awesome. I had this, I was just curious about this. We worked with a few annotation providers and of sorts. So, in some sense, the data coming in from annotation providers is not pixel perfect. I mean, it's a human at the end of the day, setting and marking certain points or segmenting certain image, etc. But if it's synthetic data, it's going to be pixel perfect, right? So how do these two data kind of qualities affect the end model if you've seen something either getting trained from manually annotated versus synthetic?
Yeah, so I can definitely speak to this, and we've actually we're going to be releasing this, or maybe released it actually in the past 2 days. So I can actually provide a link. But we just came out with a benchmark for segmentation of people, of people's faces. And there were a few very interesting things there. But one of them, for example, is the challenge of actually testing the quality of the model. So if you think about hair segmentation, for example, where you have very small hairs that are popping up, this is actually something that manual annotators have a very hard time of annotating. And so you have a real kind of limit to the quality of the model itself. And so let's say human segmentation, right, in this kind of setting even, is something that we all use almost every day with Zoom, right? We don't want our friends or colleagues, showing up in the background. And so, this is a classic use case. But on one hand, with manual annotation, you have a limit to the quality that you can get. With synthetic data, you can actually get super high quality. You get pixel perfect quality. And so the output is actually includes these very small segments. Now, what's the challenge, right? We want to measure how good we are. We want to measure how good the data is. And so to do this, you want to take a model, a standard segmentation model, train it with synthetic data, and test it against real data. Now,
Right.
this sounds trivial, right? But if you have a test set that is real data and that's manually annotated, there's a limit to also how you can test this. So
Right.
qualitatively, we can see that it works better, but it's hard to also really reflect that in numbers. And so we have a paper that we're going to be releasing now just to show this. And I think that there are a lot of interesting aspects on kind of synthetic versus real and what we can learn from this.
Awesome.
I will say that, by working on this problem for many years, we've been able to push kind of the photorealism of our simulated synthetic data to the level that the visual domain gap is negligible already. So that's really exciting.
Wow. Wow. Yeah, I've seen some of your animations that you shared earlier, and they're mind blowing. I mean, maybe I'll share some of them on our LinkedIn and Twitter, whatever we can. But yeah, I mean, I think the clarity, the intricacies, and of course the deterministic nature of synthetic data kind of helps ML developers and larger companies to have constant stream of data coming in for training. Awesome.
Thank you.
Awesome. So in terms of methods, different methods, if you can throw some light on different methods that Datagen uses to create the synthetic data, maybe to deep dive, you said that there's a core engine. If you could throw some light as to how does that at a 40,000 feet level work, if it could be broken down for someone who doesn't know this
Yeah,
much.
yeah, definitely. So just at a very high level, right? We have different catalogs or different libraries of 3D assets that we generate at scale offline, right? So we have humans that we've generated at scale, full 3D humans that are fully controllable. We've generated offline at scale. So around 100,000 unique identities that we have. Each
Wow.
of them is unique and validated through facial recognition algorithms, for example, that they're different from each other. They have no privacy issues. It's unbiased, of course, and all of that. So that's, let's say, one type of asset. We have objects and environments and a lot of different types. We have motion as well that we're generating offline. So we have these content types that we generate offline at scale. We have a main core system, right, that you can pretty much write code, pull different assets, connect them together in a very seamless way. In like 5 lines of code, you can create a person, playing basketball and shooting hoops, right? But like pretty much you have a main system that you can control the entire 3D scene and all of the aspects of that 3D scene. And then you have a generation, like the generation flow itself, where we want to render at scale all of this data. Rendering at scale is a challenge, of course. You need, high power compute, pretty much distributed system on the cloud that can generate data, pick up hundreds of GPUs the moment someone sends a generation request. And
Right.
so, this system, I think, comes to 3 parts, right? The first part, a lot of deep learning based algorithms are used, and also 3D graphics artists work together with these deep learning algorithms engineers to generate this content. The second part is a lot of software engineering around fully controlling 3D graphics engines, and we use multiple different engines. And then the third part is really distributed compute on the cloud at scale with all of the challenges and all of the technical kind of nuances there. Again, we have an amazing team, very multidisciplinary. But these are the main high-level aspects of it.
Awesome, awesome. So yeah, I mean, there's these assets that you've created offline, and then there are these deep learning core that kind of pulls all of these required assets, and then something happens real time when someone asks you for some synthetic data. Awesome, awesome. That helps us understand the system. Um, so we spoke about computational challenges. You mentioned that uh, both to create offline stuff as well as something that you need to create real time. I'm sure there's a lot of computations that's needed. So what are some of the challenges that you've seen internally, and what's your current stack look like, and what scale are we talking about? If you could kind of give us a sense of that.
Yeah, so for example, to generate the synthetic identities, that's a real, challenge, right? And that's something that we do at scale, and we're constantly growing this. We want to reach over 1 million identities in the future. And so one of the challenges, right, is that we're generating these super high-res texture maps. So these are 8K texture maps that we're generating using diffusion-based systems. And so, like, how do we do this, right? And how do we now scale it up from 10,000 to 100,000 and from 100,000 to a million, right? And there are different challenges that we go about when we try to scale this up. And so definitely the compute is super important to optimize over time. And we're both advancing algorithms, doing things in order to also lower the memory footprint of these algorithms. And then, of course, you guys are doing great things as well. And so there's the connection there. I think that's really important. With respect to like optimization allows you to scale pretty much. It comes hand in hand, at least from my perspective.
Right, absolutely. I mean, we found that problem a couple of months, or at least a year back, in fact, where we saw certain models just taking up too much of memory on GPUs. In terms of the stack, I just wanted to draw some light on GPUs, right? Like, are GPUs also very critical in your generation process? On a high level, how much of GPU dependency does synthetic data generation have compared to CPUs? Let's say.
Yeah, so both the deep learning based algorithms are very GPU intensive and they're expensive
Right.
to run. And also the rendering itself, so 3D rendering is also GPU intensive and requires a lot of effort to run at scale. Both of these we do on the cloud. Yeah, we pretty much, we've built a system that can actually run an enormous amount of jobs at scale based on a dynamic DAG that's being built as the job runs or as the jobs run. It's quite a challenge, but it's pretty much like orchestration at scale on the cloud, and we have hundreds of GPUs that run when you send a generation, and you can generate 10,000 data points, 100,000 data points, a million data points. We know how to handle these different workloads, generate this at scale, and of course, provide it to these customers in a super seamless way. So the customer doesn't do anything, right? Like they don't feel any of this pain, right? We've created the system in a seamless way almost.
Right. And all of this is done on the cloud. There's nothing on premises or any other kind of setup.
No, on-prem we have a few cool computers that our algo team uses to test out algorithms, but only R&D is done on-prem.
Okay. Okay. So maybe like 90% or above of computation happens on the cloud.
Yeah. Even most of the R&D is on the cloud, right? But
Got
there's a
it.
bit also on-prem.
Got it. AWS wins anyways all the time.
Yeah,
Or
yeah.
whichever cloud provider you're using. It just
It's the
becomes
best business model, right?
yeah. Awesome, awesome. So yeah, I mean, I think we touched upon this optimization problem, right? So just connecting the dots between what we're working on at Segmind, which is optimizing generative models for faster, cheaper inferences. Wanted to understand, how do you see inference optimization play a key role in tech going forward? We have chat GPTs, we have image models, and a bunch of new models that are coming. But what we see from our perspective is they're working really well for a lot of use cases. But we feel this is literally the day zero or day one of these models coming out, and there's so much optimizations to happen. And in fact, that's why having a quick conversation with my co-founder, what do we name these webinar series? And we're like Int8. Like we'll have to eventually go till Int8 if possible and compress all these models so that these weights and biases are stored as Int8 rather than floats. So how do you see this inference optimization play a key role in this generative AI tech?
Definitely. So I think that, from a strategic perspective, it's critical that we actually make these models extremely efficient. The efficiency of search, if you look at, search as a product, right, is extremely impressive, right? Like you can search, get back million results, milliseconds, of course, and also cost-wise, it's reasonable for Google. With respect to every single time we search, it costs Google something, right? Now, if you take ChatGPT as in comparison, right, and you look at the cost structure there, it's around an order of magnitude more. That's the estimation, at least. And so this really poses significant challenges on the ability for this kind of technology to compete with Google, right? And so you have the same challenge with respect to image generation, for example, or any type of audio generation. It's much, much cheaper today, at least, to search for something that exists than to generate it. Now, this doesn't need to be the case necessarily. And I think that the moment that we're able to maybe create a much more even playing field, that will be a moment where from a business perspective, it might even make more sense to generate something than to search for it in different ways. Or it may, make equal sense, and then you'll get either something super custom or something that already exists. And so I think that there's a lot of interesting dynamics that happen as we optimize these models and create much more of an even playing field between search and generation. And it could be generation of any type of media, right? From music to text to images, etc.
Right. Interesting comparison. I mean, search versus, because I mean, it's just taken for granted that search is free, which basically costs, 1/100th of a cent or something like that for Google. And yeah, I mean, I think there's so much to do before we reach there in terms of generative AI. Awesome. So drawing, to a couple of use cases in Datagen. We have around 20 minutes, so I'm just kind of bringing out some questions that I've had for some time. In terms of use cases for synthetic data, on a high level, it's computer vision. Could you help us understand what are the top couple of use cases that you see which are, bang on target for synthetic data? We see hundreds of use cases, but I think from your perspective, a couple of top use cases. Of course, I see autonomous driving or driving related stuff being kind of done by Datagen. So one or two or three maybe use cases that you are seeing from your perspective.
Definitely. So I'll talk first of all about a kind of the most famous public use case, which is actually the HoloLens, right? So Microsoft developed their AR device, the HoloLens, and all of the features there, every single feature was really synthetic data based. They had an amazing team with Tadas and many of the other kind of big names in the synthetic data space. Errol Wood worked there, many big names, and really, there they really focused on hand gesture recognition, eye gaze estimation, face key point estimation, many different ways of understanding people using synthetic data, as well as also the room around, right? So in order to understand where the headset is positioned in 3D space so that you can interact with the environment around you, you really they generated pretty much synthetic data for this as well. And so this is all public, and you guys can check it out. They created different papers on it. One of the most famous ones was Fake It Till You Make It. So highly recommend to check it out. And it really shows off the approach of simulated synthetic data at scale, human-centric, in order to solve real-world kind of challenges. So AR, VR, these kind of folks, these were the first kind of groups to adopt this type of approach, as well as the automotive space, which is also an enormous space. For the external side of the vehicle, every single automotive OEM today has their own simulation approach. They all kind of simulate cars driving around, simulate cities, etc. Tesla also announced this, and it was actually quite interesting because originally they were against simulation a bit, and then they announced it and showed actually how they used it to iterate quickly and solve different edge cases. So I think that's also really nice and promising. And the inside of the vehicle is one that's also very interesting for us, and one that we have amazing partners in all over the world actually, and really they're doing great things. The idea is that inside of the vehicle you have many features that require computer vision in the future vehicles, right? Which include, detecting when a driver is going to fall asleep. They include detecting when you forget a baby in the car. They want to understand where someone's looking, if they're looking at the mirror or not. Maybe it can beep if there's someone that's coming quickly on the side. They want to customize the airbags to the body type of the person in the car. So for instance, if you're a smaller woman, for example, they would customize the airbag expansion based on your body type, based on the 3D kind of analysis of you. Or if you're someone that's very large as well. Today, there's no customization. It's like one airbag for each person. Detect if you're drunk. Anyway, there are many, many different features, right? And this is just in the inside of the vehicle. Smart fitness applications, super, super cool things. You have smart doorbell devices, and the list really goes on. Cosmetics, we work with a bunch of cosmetics companies on doing high resolution analysis of the skin, early detection of various kind of wrinkles and pimples and all these kind of things that they're creating solutions for. And really, it's super exciting to see. If you take a step back, at a very high level, computer vision is the connection, right? And doing not generative, but just standard computer vision is the ability to take in video and images and extract some kind of interesting or valuable information in a structured way from that image, right? So, at a very high level, it's the connection between the real world, which we can take a camera and capture, and extracting from it structured information that we can use in our digital world. So the connection between the real world and the digital world. Now with the generative stuff, it's the opposite, right? It's like using the digital and generating new real world like images. So it's an amazing field to be in. Really, really fun stuff.
Awesome. Yeah, looks like there are a lot of use cases that you can kind of diversify into and build on top of the core engine that you're building today into newer applications that are coming out. Uh, so I was thinking about gaming as an industry and how does synthetic data tie into gaming? I mean, now that you're able to create, almost on the fly with lot less compute. I mean, just imagine games like GTA, right? Like so much of work had gone into creating the city and the textures and everything. Do you see any tie between synthetic data generation? Do you feed into gaming? Have you kind of used anything from gaming industry? How do these two industries tie?
Yeah, we've gotten many requests, but we've so far been very much focused on computer vision engineers. There is an enormous amount of decisions, product decisions that are made in order to create the best engineering focused tool possible. That said, the technology is definitely progressing, and we see many ways to positively impact the gaming industry. If it's generation of 3D humans, for example, that can be assets in games. If it's creating you, right? Creating you as an avatar in the game itself. Also technology that is very kind of tightly coupled with what we're doing. If it's generation of 3D objects as well. And there are many different layers of this really. And you can pretty much imagine that in the future, you'll be able to customize any aspect of the game itself in an automatic way with text. And also the interactions are going to be much more realistic. So, having a synthetic, human kind of punch let's say the glass behind me, and it could actually shatter even if it wasn't pre-programmed to shatter. Having these more realistic physics or pseudo physics based simulated environments. Now the tech to get there has a lot to do with synthetic data and also creating this data at scale and creating different 3D assets at scale. And so there's a lot of overlap. But right now, Datagen is very much focused on computer vision.
Got it. Makes sense. I mean, there is so much to do that you'll have to kind of focus on one of the areas and kind of build a vertical solution there. And that gives you a good platform to kind of eventually use it with gaming or any other industry. Um,
Yeah, metaverse as well, right? Like metaverse is one of the kind of domains that we've gotten asked a lot about, and
right,
it's something that our digital humans can fit in very nicely to.
right.
But yes, it's something that's much more future looking than a today thing.
Got it. In terms of temporal stuff, what I mean by temporal is, okay, you've created this human body. Now they need to kind of move their hand up or do certain activities, and that needs to look natural. Is that, I mean, how do you tackle that problem? Where is it today? Like, are you able to create very natural motions of fingers, hands, eyes, etc., or is that still a challenge to be solved, or where are we there with respect to that?
Yes, so it's a great question, and it's very challenging for most groups to do this. We actually have quite unique assets that we leverage in order to solve this problem, and we're able to. So just at a very high level, we have our own in-house motion capture studio, and so this allows us to actually, and this is Hollywood grade, full kind of suit and optical sensors and everything, all calibrated, and professional staff also that can run this. But pretty much whenever we want to capture new base data, base motion, we actually can walk over, and it's not too far from me where I'm sitting. Walk over, set it up, right? And then generate pretty much enormous amounts of high quality motion data with fingers, with body, with facial expressions all together. This is something that's a very non-trivial capability, but it's something that we felt was very important to build out. The essence, right? The ability to create really good data relies on your ability to create really good base assets that you're basing your data off of, right? So to get realistic motion and be able to generate this realistic motion, even using different diffusion-based algorithms, you need high quality base data to train these
Right.
algorithms with.
Right. Wow, this is super interesting. I mean, what I feel is, I think one of the reasons Datagen is doing so great is because we've been able to bring interdisciplinary, um, talent, which includes animators, cloud professionals, deep learning, machine learning guys, computer vision guys, all of them onto a single table, and then build all of this out. I can see how challenging this would have been, but I mean, amazing job
Thank you.
at
Thank you so much.
Awesome. So maybe I'll just kind of try wrapping it up in the next 5 minutes. One final thing to kind of what I wanted to ask was, what are some of the challenges that are yet to be solved in this space? Maybe two spaces we can talk about. First is synthetic data, and then generative AI. But more importantly, from your perspective in synthetic data, what are some of the large challenges, be it algorithmic based challenges, computation challenges? What are some of the one or two big challenges that are yet to be solved in this space?
Yeah, I think it's a great question. I think that there's just every time I look at what we have and what we need and all these things, I always see that there's so much potential still to still build, of course. And I think that it's really about scaling up right now. So the ability to scale up to, let's say around 100,000 unique identities, which is significant, right? It's
Right.
enormous, and they're all super high res and different from each other and everything. It's a big challenge, but scaling that up to a million, to over a million, to all these, that's one really big challenge. If it's motion, also scaling that up to millions of unique motion. If it's environments, et cetera, et cetera. So I really see the promise of these diffusion-based systems to help us scale up all of these different directions and vectors. And we're, of course, working very hard on it. But I think that that's one of the big challenges today in the synthetic data space. In the generative AI space, I also see many different challenges. One of the big ones is definitely around optimizing these models to make it really financially possible to create this at scale. I think that stability on
I think we lost you there, Gil. Your headphones.
Can you hear me now?
Yes.
Okay, great. I think my headphones just died. So yeah, I'm saying stability on one hand, stability AI on one hand released their stable diffusion models, which is amazing to the open source community, and that's really positive, and that really allows the tech to progress significantly. But I think that no one has yet provided a really good cloud-based service for these kind of models, and so I definitely see that the optimization aspect is one big challenge. And if it is solved, then we can get, cheap and also easy to interact with, lower barriers of entry, ability to edit and generate both, audio, video, text, all of these things at scale. And that's really exciting for me. So I definitely think that optimization is one of the big ones on the generative AI side. And also, just the quality, right? Like Midjourney 5 is absolutely incredible. But we can definitely see how it gets 10x better, and I would even say 100x better than it is right now,
Absolutely.
including both image, video, 3D, all of that.
Absolutely. I mean, that's what keeps us excited because we've seen so much scope in improving these models, at least at inference side. There's a lot of work happening in improving the quality of outputs itself, but inference side as well. And yeah, that's something that keeps us excited. Awesome. Maybe and first of all, thank you so much for doing this today. I think we have a lot of people joining from different parts of the world, and we will put this online on YouTube as well. So I'll just open it up to questions and just take questions for the next 5 minutes. I can probably read it out from the chat as they pop up, and then in the next 5 to 10 minutes we can wrap this up. So I have a question. It says, "Hey Gil, it's from Harish. How do you see newer models like ControlNet being applied to synthetic data generation, like novel digital humans?"
Yeah, definitely. It's a great question. I'm not going to make any product announcements today, but definitely keep your eyes open. We see that there's a lot of opportunity there, and we'll talk more about it soon.
Awesome. So everyone follow, Datagen's LinkedIn and Twitter, and there's going to be some announcements soon. I have the next one from Ashley Goldstein. How do you see artists using Gen AI as a tool for creating assets for SDG?
Yeah, for data generation or simulated data generation.
Simulated data generation. Okay.
Yeah, it's a great question. I think that we're going to see more and more automation, really. So there's going to be a lot of automation around basic assets, and then where the artists are going to come in is around really custom assets. So or customizing them in unique ways while maintaining quality. So I think that over time, the artists are going to have more focused on the nuance, and the broad, large catalogs of objects are going to be more automated over time.
Got it. There are a bunch of them flowing in. This one's from Ritesh, and he's asking, how do you think NERF can replace 3D generation?
Yeah, it's a great question. Right now, NERF is mostly about rendering, so it's very powerful for rendering, and I think that there are many unique aspects that you can do with NERF, really connecting the real world and or turning the real world into a 3D environment that you can then edit and manipulate and all of that. There are a lot of challenges though. I do think that in the very long term, we will see NERF and these graphics engines combining much more tightly. But right now, it's very hard still to edit in NERF. Although there are new papers in the subject, it's still quite hard to edit in NERF. And it's also very hard to represent dynamic information in NERF. So right now, it's not yet ready to take the spotlight. I think it needs to implement the basic building blocks that we see in the graphics engine in order to really use it. The advantage of NERF is that you can do things like semantic editing, right? So you can write text and edit the NERF 3D information. And so that's a really powerful capability on one hand. On the other hand, things that are relatively simple, like rigging someone or compositing multiple objects together, they're still quite hard to do and interact with. So I see in the future really the NERF capabilities growing and then combining into the graphics engines, be it Blender or Unreal Engine or Unity.
Got it. Cool. Maybe we have two more. Chirag Raman is asking, curious to hear your thoughts on simulating believable social behavior data sets at scale for digital humans, especially given the privacy concerns in recording such data sets in natural settings to obtain source data.
Mm-hmm. Yeah, it's a great question. So you have a few different levels of privacy, right, that are challenging. One is just the person's identity, so any bio-identifiers. And so when we generate our data, we have over 100,000 identities that are, that we have base data for, right? We have high resolution 3D scans that we've collected at scale, and also an enormous data set of 2D people at scale, right? We have multiple layers of privacy maintaining algorithms pretty much there, as well as we validate that the end data that's generated is not similar to any of the base data people. And so in the end, there's no privacy issues with the data that we're actually providing to our users, and they can use it with a clear conscience and no issues regarding maintaining privacy and stuff within their organization. So sharing privacy, like PII data or personally identifiable information data in organizations is also challenged, especially within larger organizations like Amazon, Google, Facebook, all of these. And so, what's really good about our data, and one of the reasons that it helps teams accelerate themselves, is because they don't need to deal with any of this PII information.
Right.
That's super, super important.
Right.
Recording dynamic motion, it's all part of the same puzzle. We separate the two challenges of generating humans and generating motion, and we have different ways of combining them together, of course.
Right. It's completely synthetic, basically. So no PIIs involved at all.
Mm-hmm.
So, okay, he's saying, I meant simulating social behaviors because scans are usually in non-social contexts.
Yeah. So social behaviors is a great thing. Our motion capture studio can actually capture multiple people also. And so this is part of what we're simulating. We are also working on algorithms for generating multi-human motion. It's still in progress, but anyone that's interested, definitely check out. You could just Google human motion diffusion models and check out some of the newest papers there. Super interesting field, progressing in an amazing way and really leveraging a lot of the capabilities of diffusion models for motion data generation.
Got it. We'll just take one more. Ashley Goldstein, are you seeing software as being a blocker for creating and simulating synthetic data?
So definitely not as a blocker, but it's an enabler. We have an amazing software team, and they work on the entire stack of this problem. Super dedicated engineers that work really, really nonstop, and these guys and girls are really, really top tier in how they think about the problems, both at a high level and also the low level. Clean code, of course, and all of the software engineering kind of best practices that go into creating this kind of code base. But there's a lot to do. So it's definitely a challenge, but it's not a blocker. It's something that we're every day progressing with and every day expanding our capabilities.
Right. I mean, it's basically software is helping us build these modules, and makes sense. Awesome. I think we're at the end of the webinar. Thanks so much, Gil. It was super interesting. Hopefully we should do one more in 3 or 6 months to see where technology is headed. Everyone who's on the webinar live right now, you can follow Datagen on LinkedIn and Twitter. You can follow Segmind as well on LinkedIn and Twitter, and keep following all the updates in synthetic data and generative AI. Thank you so much. Thank you, Gil.
Thank you.
See you soon. Bye-bye.
Bye-bye. Thank
Bye-bye.
you.